Hey guys, this is going to be a review for your test today. This is some important information that I think you should have written down on your note card. How to convert between exponentials and logarithms, the properties, the product rule, the quotient rule, and the power rule, which I wrote product twice. This is your power rule. And then your transformations. So remember, you still have your A, which is your stretch, shrink, or reflect. You have your H, which moves it left or right. That's inside the parentheses. And then your K moves it up and down. Your range is going to be all real numbers, and your domain is going to be X is greater than whatever your asymptote is. So your asymptote is X equals H. If there is no H, it's 0. If it moved to the right, it's going to be a positive H. And if it moved to the left, it's going to be a negative H. It's going to be the opposite of what you see in the equation. Okay, so let's go ahead and work through some examples. So here it says, what is the inverse of f of x equals e to the x? Okay, remember when we're looking to solve for an inverse, we're going to rename the function y. We're going to switch our x's and y's, and then we're going to solve for y. Anytime we have something up here as an exponential, we want to rewrite it. So because it's base e, we're going to use the natural log ln, and then we're going to flip-flop our exponent and our argument. So we have ln of x equals y. Now that we have y by itself, we can just rename the function as f inverse of x equals ln of x. Okay. Now let's look at this log question, finding the inverse of log. This one is just a little bit tricky because there's no base, but we know that when there is no base, your base is 10. Okay, so we're going to go ahead and switch our x's and y's and solve for y. So we have x equals log base 10 of y, and now we can rewrite it as an exponential. So we have 10 to the power of x equals y, and now that that equals y, we just rename the function f inverse x. Okay, now let's look at a little bit more tricky one. Okay, so same steps, we're going to rename the function y and switch our x's and y's. So we have an x here and a y here now, and we rewrite everything just like we see it. Log base 6 of y minus 3. Now the base, our log, is isolated. There's nothing after it or before it on that side of the equal sign. So now we can rewrite it. So remember, we write it as our base, which is 6 to the power of x equals y minus 3. And then using your opposite operations, we can add 3 to both sides. And we get y equals 6 to the power of x plus 3. And we'll call that f inverse x. Okay, so now if we want to go from an exponential to a log to find our inverses, we want to isolate our base and our exponent. We want to be careful not to try to multiply that 3 or distribute that 3 inside because it doesn't have the same exponential attached to it, so we can't really do it that way. So let's go ahead and switch our x's and y's and rewrite our function 3 parentheses 2 to the power of y plus 5. Okay, so we need to move this 3 first. In order to move the 3, we're going to divide both sides by 3, and that 3 over 3 goes to 1. So we have x over 3 equals 2 to the power of y plus 5. Now, because our base and our exponent is by itself, and the thing that we're solving for is in the exponent, we're going to go ahead and rewrite it now as a log. So we have log base 2 of x over 3 equals y plus 5. We still have to get this y by itself, so we're going to go ahead and minus 5 to both sides. But when we minus that 5, we want to put it after the parentheses. So we end up with y equals log base 2 of x over 3 minus 5. And then we'll rename that function f inverse because we have y by itself now. Okay, so a little tip and trick for when you're taking the test. We know inverses flip our x and y's. So if you want to graph the original equation and get a couple points from the table, and then you want to graph the answer that you think it is, if your x's and y's are backwards, then you know you did it right. So go ahead and pause the video. Try this one. This is what you should have ended up with. Notice that x plus 4 over 3 had to be isolated first to get your base by itself. And then once you did that, you're able to rewrite it, and still you have to get the y by itself after that. Okay, so let's talk about log properties. Now, sometimes I like to break it up into different pieces. So notice this one, it wants us to expand it. I would look at this and I say, okay, this one and this one multiply together. So that's our product rule. And I'll rewrite that one as a product rule. Log m squared plus log n. Now, if I'm looking at this one, I notice that this now is a power rule, and we just write this out front. So we have 2 log m plus log n, and that's it. So that's how we expand. Now let's look at a condensing problem. Again, I like to look at it in parts. So I'll look at this part because I'm like, okay, these two have the power rule. And we know we're going to take this number and make it an exponent, take this number, make it an exponent. So we have the log of s to the power of 3 plus log of t to the power of 2. And now when I look at this, I'm like, okay, I have a plus sign in between these two logs, and I'm trying to get it down to 1, and that's our product rule. So I'm going to multiply that s cubed and that t squared, which is pretty easy. We're just going to write it next to each other. So we have s cubed t squared, and that's it. So let's expand an ln, okay? So ln operates just like a log. So we still have the same rules. Notice I have a division sign in here. So I'm going to look at this as the top and this is the bottom. And I'm going to rewrite that with our quotient rule, which is ln of 2x minus ln of 5. But I also see another rule here because I have two numbers multiplying by each other. Well, a number and a variable. So I'm going to go ahead and split that using our product property. So I have an ln of 2 plus my ln of x minus my ln of 5. Okay. So I want you guys to go ahead and try this one. Pause the video, see if you get it right. So if you were doing this problem, you should have noticed that this is product property. And then after you do the product property, which is x times y, you also have that quotient rule, which brings the z to the bottom. But notice that your base is 7. So you want to make sure that your answer has a 7 down here as well. I think I have one more for you guys to try. This one is a little bit extra, but I want you to go ahead and expand it, see if you can get all the rules there. So if you got this, you got it right. Oh, one more. Now this has a ln. Don't get scared because there's an ln instead of a log. You should have got ln of 19 plus ln of u plus 2 ln of t. Okay, let's look at some key features that you're going to see for logs. So it's asking what the x-intercept is. Now remember, you can always analyze your graph for a zero if you have an equation. You could also trace your graph using graph trace and find your x and y intercepts. Okay, in this question right here, we're looking for where it touches the x-axis. So it looks like our x-intercept is at -6, 0. And then the vertical asymptote is right here. It's labeled for us. Remember, vertical is the opposite of what our axis do. So we have x equals -7. And then for domain and range, all real numbers, pretty straightforward. Domain, our graph is to the right of our asymptote. So we have x is greater than -7. Now let's identify some transformations. So remember, we can put a box around all of our numbers. So I like to put a box around what would be my A, what would be my H, and what would be my K. And then if there's a negative out front, I'd put another box around that because I know that's going to give me a reflection. So this 4 here is a stretch. This -3 tells me that we're moving to the right 3. And this +2 tells me we're moving up 2. And remember, for our asymptote, it's x equals, because they're vertical asymptotes. If it moves to the right, it's going to be positive. So x equals 3. Okay? Now let's write an equation from some given transformations. So notice the base is 33. So it says we have a reflection. We know the reflection goes out front. So I'm going to go ahead and write f of x equals negative. That takes care of this one. Let's see if there's a stretch or shrink. There is a shrink by 1/3. So that goes in front of the log. We have log base 33, parentheses x. Does it move left or right? Yes, it moves left 3. So we know a left is going to be a positive h. So I'm going to put +3. And then it says it moves up by 3. So I'm going to put a +3 here. Okay. Now, because it moves left 3, we know that our asymptote is x equals -3. Okay, let's go ahead and try this one. Pause the video. If you got the domain was x is greater than 2 and your range was all real numbers, congratulations, you got it right. Now, let's go ahead and practice solving. Okay, this is really the last step, I think, for your test. So anytime you have a number up here in the exponents, you want to isolate your base and your exponent, and then you want to rewrite it as a log. So we have log, our base is 9, our exponent is 4x, and our argument is here. So we have log of 7, log base 9 of 7 equals 4x, okay? And then we want to get x by itself by using our opposite operations. Anytime there's no symbol in between a number and a variable, that invisible symbol is multiplication. So 4 is multiplying by x, so we're going to divide by 4. Okay, so x equals log base 9 of 7 over 4, and you plug that into your calculator. Now let's look at another example. We have log base 14 of u minus 6 equals -5. So this is just the opposite of what we've been doing, but we still want to isolate the log. So you're either isolating the base and the exponent, or you're isolating the log first. So notice we have a -6 next to it, so we're going to +6 to both sides. Now we have log base 14 of u equals 1. And we need to get that u outside of the log, so we're going to rewrite it as 14 to the power of 1 equals u. And once you plug this into your calculator, or you just know 14 to the exponent of 1 is 14, you know u equals 14. So go ahead and try this one. Please don't forget to isolate your base and your exponent first. So if you switched it to ln and then you minus 2 out of 3, plug that in, you would get 0.066. I have another one here for you guys to try. Notice that both sides have a log. And because both sides have a log, we want to just ignore it, okay? And set those arguments equal to each other. So go ahead and pause the video. If this is what you got, good job, okay? So this turns out to be a quadratic. So you want, because it has y squared, so you want to set it equal to 0. And then you could solve it by graphing it and looking for your zeros, or you could solve it by factoring. So I did it by factoring. I put my a times c on top, b on bottom, and then my two side numbers were 5 and -1. So once you set your factors equal to 0, you get -5 and 1. And that's it for our review today.